In class, I've spent some time talking about cumulative binomial probabilities. I've looked at the binomial tables and shown you how to use those. I wanted to go through and give a quick little video showing how we use the Excel binomial.dist function to get similar values. And you can see here, I'm starting in this little demonstration. Let's assume we have a binomial with n equal 20 and p equal 0.4. Now, to find the binomial.dist function, you can do it a bunch of different ways. You can come over here to formulas, insert a function, and you can find it that way. There's a whole lot of ways to do it. However, a really simple way is to just go into a cell and type equal and then start typing binomial. And then you get a couple different options here. The one I'm going to talk about is the binomial.dist function. And then you click on that. And when you click on that, it opens a parenthesis, and you can either type numbers in, number underscore s, the trials, the probability s, cumulative, or you can go and click on this and it opens up the binomial distribution function argument screen. And so here I'm going to put in the number of trials and the probability of success. And identifying a binomial, you need a value of n and p, so those things are going to be pretty much known as you enter into this. The next thing is to come up with the number of successes that you're interested in. Let's assume for a second that I'm interested in the value 7. Find the probability no more than 7 of the trials are successes. Find the probability exactly 7 of the trials are successes. Find the probability more than 7. Let's say I decide that 7 is the key. And the thought process here is very similar to what I've gone over in class in the notes concerning working with binomials. And typically I approach it from, let's try to get to less than or equal to's. So let's say I want the probability involving 7. So I'm going to put in that value of x. Now the other possibility here, the other feature that you need, or the other item that you need to fill in, is this cumulative function. And you can either say true or false here. If you say true, if I type in true, you're going to see, and you can see it doesn't apparently matter if you do capital or not, you can see the value here, 0.41589. That's what you see right here in my cell. I use true for that function, and that gives me a less than or equal to. So if you want a less than or equal to probability, you put in the value true here. If, however, you want a false, or you type in false, you get an equal to probability. That's the probability x is equal to 7. So let me cancel out of this, and I'll just come up here and show you what I put. And you don't need to go through that menu. You can just do equal binomial.dist and open a parenthesis and put these 4 things in. The first one is the number of successes you're interested in. N and P are next. And then true gives you the less than or equal to probability. Oops. False gives you the equal to probability. Now we can compare this to a binomial table, and you're going to see that when you go to n equal 20, p equal 0.4, and you get n and find a value of 7, you're going to see 0.416, because the binomial table gives less than or equal to probabilities rounded to 3 decimal places. You can see here that I've copied and pasted part of the binomial table, n equal 20, p equal 0.4. Come on down to the value at 7, you can see 0.416. That is rounded to 3 decimal places. You'll also notice if I take the probability x is less than or equal to 7 and subtract the probability x is less than or equal to 6, I'm going to get 0.165, I guess 166, which is the value you see here. And so the values you get from Excel or the tables are going to be exactly the same. It's purely a preference. Sometimes I'll ask you to use one or the other, or require you to use one or the other, but most of the times you get to choose. Choose the technique, whether you're a table person or an Excel person, to solve binomials. When you have questions, if you have questions, reach out to either myself or the teaching assistants, and we'd be happy to help you working with the binomial function, the binom.dist function. Good luck.